10.7 Adding and Subtracting in Scientific Notation. To add or subtract numbers in scientific notation, with the same power of 10, add or subtract the factors. So that one is like problem A, where you have a 10 to the third power and 10 to the third power. Because they are both the same, that would allow you to just add the factors. Now, when the numbers have different powers of 10, first you need to rewrite the numbers so that they have the same power of 10. So A and B, the directions are from example 1, adding and subtracting in scientific notations. We're going to find the sum or difference and write our answer in scientific notation. So let's start with letter A. I'm going to erase this. Okay. First step is to to check your powers. 10 to the third power, 10 to the third power. Because they both have to the third power, you can just add the factors. 4 and 6/10 plus 8 and 72 hundredths. So I'm going to focus on that. 4 and 6/10 times 8 and 72, plus 8 and 72 hundredths is 13 and 32 hundredths. Well, I can't simplify anymore, so now I'm going to bring down 10 to the third power. So from here, I need to make sure that my answer is in scientific notation. I look at my factor, which is 13 and 32 hundredths. That number is bigger than 10. So that means that I have to move my decimal over to the left once. By doing that, that leaves me with 1 and 332 thousandths. This number is between 1 and 10, so I'm good. Because I made my factor smaller by going to the left one, I need to make my exponent bigger by adding 1. And you want to do the inverse. So if you're making the factor smaller, you make the exponent bigger. If you make the factor bigger, you make the exponent smaller. So that's times 10 to the fourth power. Letter B, 3 and 5/10 times 10 to the negative second minus 6 and 6/10 times 10 to the negative third. From here, I will look at my my exponents. I have -2 and -3. Those are not the same. So because they're not the same, I need to go in and change one of the two. It doesn't matter which one. I personally always make the smaller exponent larger. It requires less work for later on in the problem. So to get from -3 to -2, I add 1. I am making my exponent bigger, so my factor has to be smaller. So I move it to the left once. I'll put a 0 in front. My second term becomes 66 hundredths times 10 to the negative second power. My first term, I'm just going to rewrite that. I didn't change anything with a 3 and 5/10 times 10 to the negative second. That stays the same. But now you'll notice my powers are the same. They're both -2. So now I'm going to combine my factors. 3 and 5/10 minus 66 hundredths. That is 2 and 84 hundredths. Then I'll bring down my factor of 10. My factors between 1 and 10, and my power of 10 as an integer exponent, so I'm finished. Try number 1 and 2 before continuing. So let's go over this now. Number 1, we have the power of 2 and the power of -1. Well, they're not the same, so I need to change one of them. I'm going to make -2 become 3. -2 become, oh my goodness, I'm sorry. I'm going to make -1 become 2 by adding 3. Because I'm adding 3 to my exponent, I need to make my factor smaller by a power of 3. So 1, 2, 3 to the left. So I'm rewriting the first term, 8 and 2/10 times 10 squared, plus 341 hundred thousandths times 10 to the second power. Now we have the same power of 2. And because we have the same power of 2, we can actually combine our factors. 8 and 2/10 plus 341 hundred thousandths gives us 8 and 20,341 hundred thousandths. Then I'm going to multiply this by 10 to the second power. My factors between 1 and 10. I have a power of 10 with an integer, so that's my final answer. Number 2, checking our powers. -5, they're both the same, so that means that we're just going to add the factors. 7 and 8/10 minus 4 and 5/10. 7 and 8/10 minus 4 and 5/10 is 3 and 3/10 times 10 to the -5th power. That's my final answer because my factors between 1 and 10. And 10 to the -5th, my exponent is an integer. Excellent.